The second method for solving a quadratic equation is called the square root property. This method only works for quadratic equations in a specific form. If it can be written x squared equals c, or the quantity ax plus b squared equals c, where a, b, and c are real numbers, then we can solve it with the square root property. Notice in both of these forms, the squared part is isolated and there's nothing but a constant left behind. Same is the case over here. The squared part is by itself and there's only a constant over here, not something containing an x on the right side. If the equation takes one of these forms, then you can solve it with the square root property. This is a really easy method to use. It's fast and it's efficient, but again, it only works on this subset of forms for the quadratic equation. So here's what we're going to do. To solve a quadratic equation with the square root property, do the following. Number one, isolate the quadratic term. Remember, the quadratic term is the squared term. Now remember, if I'm going to solve a quadratic equation by factoring, I want all of the terms on one side so that it's equal to 0. But I'm using a different method here. I have a different motivation, so the steps are a little bit different. As you learn all of these methods together, you'll want to compare and contrast and know for sure what each method requires. So in this case, I'm not trying to get it equal to 0. I want the quadratic term isolated. Number two, take the square root of both sides. This is where the method gets its name. Now remember, every real number actually has two square roots. One positive, this is called the principal root, and one negative. So we've been simplifying radicals like this. If I'm just simplifying a radical, doing arithmetic, that's going to be equal to 2. But if I have a quadratic equation where I'm taking the square root of both sides, then I am going to recognize there's two possible roots, one positive and one negative. Remember, quadratic or degree 2 equations have two solutions. So that's where my two solutions are going to come from. Now, after you take the square root of both sides, you may have to do a little bit more work and isolate x. But once you have your two solutions, make sure you check by substitution. So let's give this simple method a try. On example 2, we want to solve the quadratic equations using the square root property. Now, if you remember in the last video, we solved this exact same equation by factoring. But here, we're going to solve it with the square root method. You can be nimble. You can look at the format of the equation and choose your method appropriately. So to solve this with the square root method, I want to isolate the quadratic term. Remember, quadratic means squared term. So I'm going to add 144 to both sides. Now that the quadratic term is isolated, we can take the square root of both sides, remembering the plus or minus to generate the two answers. So the square root of x squared is x, and over here we have positive or negative square root of 144, which is 12. If you'll remember from the last video, those are the same two solutions that we got by factoring. So we can be confident that we've solved this one correctly. Let's look at example B. So our goal is to solve using the square root method. So we have 4x squared plus 196 equals 0. Before I can take the square root of both sides, I have to isolate the quadratic term. So the first thing we're going to do here is subtract 196 from both sides. Again, continuing to isolate x, we're going to divide both sides by 4. And 196, or negative 196, divided by 4 gives me negative 49. Now that our quadratic term is isolated, we can take the square root of both sides, remembering our plus or minus on the right side. The square root of x squared is x, and the square root of negative 49 is 7i. So we came up with two solutions in this case, and they are both imaginary solutions. So in our solution set, we have negative 7i and positive 7i. Let's take a look at that one with our calculator. So going back to the original equation, I'm going to replace x with 7i and square it and add 196. Notice that gives me on The left side, 0 plus 0i. My calculator's in complex mode here, so I can see clearly that's equal to 0. And if we looked at the same thing with negative 7i, we would also get 0. Now, if your calculator is just in real mode and you type it in, well, I thought it would give me an ordinary 0. I was wrong. But we can see 0 plus 0i is equal to 0. Okay, let's try our next example. So the first thing that we need to do here is isolate our quadratic term. And we can do that by adding 20 to both sides. This gives me x minus 2 quantity squared equals 20. Then we're going to take the square root of both sides, remembering the plus or minus over there on the right. And the square root and the square are inverse operations, so essentially they cancel. And we end up with just the radicand x minus 2. Now on this side, we need to simplify the square root of 20. Let's think of the square root of 20 as the square root of 4 times 5. Then we can split up our radical, square root of 4, square root of 5, and reduce it to 2 square root of 5. So the square root of 20 is going to be plus or minus 2 square root of 5. Now, we have a little bit more work to do to isolate x in this equation as opposed to the previous examples that we worked. To isolate x, we need to add 2 to both sides. Now, I'm going to take this 2 and put it in front of the plus or minus. That seems to make it a little more readable. So our two solutions will be 2 plus or minus 2 square root of 5. If we want to look at these formally separated in a set, we have two solutions, 2 minus 2 square root of 5 and 2 plus 2 square root of 5. Now, you're perfectly welcome to write your solutions with the plus or minus notation, or you can choose to separate them. Both of those are acceptable. Now, how do I check something like this? Well, with these irrational solutions, you can make use of your calculator. You've got a storage function that makes this process pretty easy. So the first thing I'm going to do is enter my first solution. It was 2 minus 2 square root of 5. Then over here on the left side of my keypad, I have a button called STO. That's going to put an arrow on the home screen. Now, if you look closely at all of your buttons, you can see there's letters in green on your buttons. To access those letters, I'm going to first press the alpha key, and then I'm just going to pick letter A here, which corresponds to my math button, and then press enter. So the calculator is going to take that 2 minus 2 square root of 5 and store its value under A. It did return the approximate value of that irrational number, but that's okay. We don't need that information. So now to check that solution, instead of typing in my 2 minus 2 square root of 5, I'm going to plug A in for x. So to access the A, I press the alpha key followed by the math button. That puts A on my screen. Minus 2 quantity squared, minus 20, and that gives me the balanced equation. To see that one more time, we'll store our other solution, which was 2 plus 2 square root of 5, in letter B. And then we can plug alpha B in for x and let the calculator do all the arithmetic. And we can see we have a balanced equation there as well. So even those more difficult solutions, you can still check with substitution. Let's try one more example that we can solve with the square root property. In this case, the squared or quadratic part is already isolated. So we can begin solving by taking the square root of both sides, including the plus or minus on the right. So we have 2x minus 5 equals plus or minus. Now, working on the square root of 32, we can think of that as 16 times 2. And then break up our radical to obtain 4 square root of 2. So the square root of 32 is plus or minus 4 square root of 2. As we did on the previous example, I'm going to add 5 to both sides, putting it in front of that plus or minus. So we have 2x equals 5 plus or minus 4 square root of 2. And then we can solve for x by dividing both sides by 2. And we get x equals 5 plus or minus 4 square root of 2 over 2. So we have two irrational solutions to this quadratic equation. Now, if you recall, if we have an imaginary solution, it's important that we separate it, real part from imaginary part. But in the case of real numbers, you don't have to worry about separating your fraction. If you did, it would not be incorrect, but it's not required. Okay, let's go through the process of checking this with our calculator again. So I want to store my two solutions in my calculator. The first one was 5 minus 4 square root of 2 divided by 2. I'm just going to store this in letter A again. It's going to replace what was there previously. And here I'm going to do a shortcut. Second, enter. That's going to recall what I just typed in. And then I'm just going to edit that minus to a plus. And I'm going to change that A to a B. And then we can plug in A into the original equation. It balances the equation, and we can plug in B. And we have two correct solutions. So at this point, we know how to solve by factoring, and we know how to solve by the square root property. In the next video, we'll study completing the square.